Hello everyone, as promised I am back with this part 2 of the first chapter of 10th grade, that is reflections and reflections of curved surfaces. So now the quick revision of the last video that I have already posted, and I request you all, the one who have not watched it, please go ahead and watch the first part so that you will understand the continuation of the first one. Now in the previous class I have already taught you what is normal. I have taught you what is normal, what is principal axis, what is C. C stands for center of curvature, and P is nothing but the pole. That I have already given you the definition, that is pole is nothing but the geometric center of a mirror. Geometric center of a mirror, no matter what mirror you take, whether it is concave or convex mirror. Now moving forward, we have something called radius of curvature. We have something called radius of curvature over here. One second. We have something called radius of curvature over here. That is, I'll show you. It is, this is the radius of curvature that you have. This is the radius of curvature that you have, and I'll show you what do you mean by radius of curvature and what is the definition of the same. I hope everyone know the normal definition of radius that we have and that we already know from the circles chapter that you have, or from the circle. As you know that circle has radius, diameter, circumference, like that. We have something called radius of curvature in the spherical mirror, and the radius of curvature definition remains same for convex and concave. So let me show you how does it look. How does it look now? Now suppose I have this mirror. This mirror is nothing but concave mirror. I have a one principal axis. This is nothing but PA. Once again, this is PA principal axis. This point, the point you have it over here, is called pole, and a ray of light that is coming from here, that is incident ray, is coming from here, and we have something called center of curvature over here. As I told you that whenever ray of light comes, after striking the mirror, it will pass through this point. What does it called? I'll tell you what does it called, but you should know that the distance from pole and to the radius of from pole and to the center of curvature is called radius of curvature. The distance from pole to the center of curvature is called radius of curvature, that you should know, which has been given over here, that is called radius of curvature, which is represented by letter R, that is called radius of curvature. The radius of curvature is which means that the distance from the pole to the center of curvature is called radius of curvature, as I have shown you in the mirror, as I have shown you in the diagram. The distance from here, let's say this distance is called R. This distance is called R, that is called radius of curvature. Now moving ahead, we have something that is the characteristics of the mirror, that is the characteristics of images which has been formed by the concave mirror and the convex mirror. As you guys already know, the nature of the image which is formed by the plane mirror, the nature of the image which is formed by the plane mirror, which you might have studied in your lower grade. Now just the reiteration of the same, reiteration of the same, that what is the characteristics of image that is formed in plane mirror? If you guys know, I know that you already knew it. Please comment in the comment box what is the characteristics of plane mirror that we know and that you have already studied. I know, and I'll draw it over here. You people can comment likewise while watching the video that what is the characteristics of plane mirror that we have. Now let me draw it. This is a plane mirror. Let's say, one more, let me draw it in a different way. Now this is a mirror. Now this is a mirror which has been placed vertically, the way we see our faces before we go to school, before we go for any occasion, something like that. So now this is a plane mirror which has been polished from the back, and you are standing here. The place and the image that you will get it in plane mirror is nothing but virtual image that you get it, and that virtual image is upright and erect. The way we see ourselves over here, same way we'll be able to look into the plane mirror. And one of the characteristics, the nature that plane mirror gives of a image is virtual image. We do not see our image inverted like this. We always see our image to the same height and also, yes, this is the type of image that we get. Now the distance of image from the mirror and this distance that I am talking about, this distance and this distance remains same. Let's say if this is 2 centimeter or 2 meters that you have, 2 meters, this image distance from the mirror will also be same. That is 2 meters and 2 meters. And image is virtual. And there is also something which you have studied that is called lateral inversion. Lateral inversion is nothing but if we raise our right hand in the image, we will be able to see that left hand is getting raised up. This inversion that we see is called lateral inversion that happens in plane mirror. Now the same characteristic that we have seen for plane mirror, we'll see it for spherical mirrors that we have. Spherical mirror that we have, and the first one that we are going to look into it is concave mirror. Now before we go to ray diagrams of the concave mirror or a convex mirror, there is a new thing that you should also know, that is something called focus. Focus, which has been explained in this diagram, I'll show you where the focus lies. Now this point is called focus. Now what is focus according to you guys? Now let's say focus is nothing but, now if you see the diagram clearly, let me zoom it for you. If you see the diagram clearly, now this diagram explains that we have center of curvature, we have focus, we have pole. Now focus, what is focus? Focus is nothing but it is a point, or it is that point from where reflected ray pass. Now how does it look? Let's say this line which is coming, this is an incident ray. After striking the mirror, it is passing through one point. It is passing through one point. Now this is an incident ray and this is a reflected ray that we have. This is the incident ray and this is the reflected ray. This is the reflected ray that we have. This is the incident ray that we have, and this ray is nothing but reflected ray that we have. Now all the reflected ray that we have, no matter how many incident ray we have, and that is coming and striking on the mirror, all the reflected ray will pass through one point that is called focus. All the reflected ray will pass through one point, one common point that is called focus. That is called focus. Now you say, let's say this ray diagram, this incident ray which is coming from below, after striking the mirror, as I told you, the reflected ray will pass through focus. Now see, this is passing through focus. Now let me draw this for you. Let me draw this manually for you over here. Now let's say I have this concave mirror. I have this concave mirror. This is a principal axis. This is a principal axis. This is pole. Let's say this is center of curvature. Now this point is called focus. As I have explained you, whenever any incident ray comes, after striking the mirror, it will pass through a point which is called focus. A point which is called focus. Now this is one ray of light. I am drawing it once again, one more. Again, whatsoever, wherever it is striking the mirror, all the reflected ray, it is compulsory that it will pass through focus. It will pass through focus. But yes, the angle of incidence and angle of reflection will be different for all the incident ray, the different incident ray that we are getting, the different rays that we are striking, that we are getting and striking the mirror. Let's say we are getting from down. As I told, the reflected ray will pass through common point called focus. So I hope I made it clear what is focus. Focus is nothing but it is a common point from where all the reflected ray pass through it. Now moving ahead. Moving ahead. Over here in this diagram, the same thing has been explained, which is there in your textbook. That is called figure number 4. That is called figure number 4. Now we have something. Yes. Now that I have, whatever I have explained, that was for concave mirror. Now this is something called convex mirror. As I have already told you, concave mirror is converging mirror and convex mirror is diverging mirror. Convex mirror is diverging mirror. Now how do you say that? How do you say that? Now this is, let's say, as I have told you, whenever incident ray comes, after striking the mirror, it is getting diverged. It is getting diverged. But to get the reflection of the same, what do we do is, we drag this line that we have, we drag this line, which we drag in this line, as I told you, that all the normal line of incident ray we have will coincide at one point that is called center of curvature. This is the normal ray that is coming and coinciding over here. Coinciding over here. As you know that this is the incident ray, this is a reflected ray that we have. In between, if you will draw the diagram, if we'll take a 90 degree and we'll draw it, that will give us 90 degree. This is giving 90 degree. This is normal. This is normal, which you have already learnt it in previous classes. Now this is a diagram for convex mirror, which is a diverging mirror. Now if you can see, all the rays are getting diverged. All the rays are getting diverged. Now all the things remain same. Principal pole remains same, focus remains same, center of curvature remains same, the diffraction remains same. Only the thing is, ray diagrams differs. Ray diagrams differs. Now moving ahead we have something over here. If you read this activity, which is nothing but it gives you one of the characteristics of concave mirror, concave mirror. Now in this diagram we have concave mirror which is placed at one end, and we have a candle which is placed on the other end, which we will consider as an object. Now we have a screen in between. If I zoom this, if I zoom out this, you will be able to see that. The diagram that I have, the image, you can see that the image is inverted. The image is inverted over here. If you zoom it, you have it in the textbook also. If you see this, image is inverted over here. Inverted is nothing but the image is in opposite end. It is not standing like this. It is just the opposite. As you can see, this is virtually standing. This is standing, but the image is opposite of the same. This is one of the characteristics of concave mirror. But while you will learn it further, I'll draw the ray diagrams that we have. In concave mirror, we have 6 cases. 6 cases, and each cases differ. And there you will learn how the ray diagrams are getting formed and how the images are getting formed when the object is kept at different places. When the object is kept at different places. Yes. So, as I told you, this is one of the characteristics of concave mirror that we have. Concave mirror always forms, not always except in one case, concave mirror forms inverted image. Inverted image is nothing but the image which seems to be opposite in the end, or it seems to be ulta. Let's say ulta. This is the one which is standing in vertically, and again it comes like this opposite. That is called inverted. That is called inverted, which has been shown over here in the diagram. This is one. This activity is only to give you one of the characteristics and what kind of image is getting formed in concave mirror. We'll get to know it further better when I'll explain you the ray diagrams. Now moving ahead. Now over here, this is the, if you perform this experiment, you will get to know what kind of image is getting formed in concave mirror. Now before we move to a ray diagram, how do we draw the ray diagram and what are the rules that we have for to draw the ray diagram of the same, I'll teach you the rules. Before we move ahead, there are few rules that need to be followed before we draw the ray diagrams for concave and convex mirror. For both of them, rules remain the same. There are 4 rules that we have. Now the first rule, which says that, let me draw it for you so that you will also understand. Yes, the first one that we have is, let's say this is a concave mirror. This is a concave mirror and we have a principal axis PA. This is a pole, this is focus, and this is center of curvature. Now this is center of curvature. Now the first rule says that if a ray of light which is coming from infinity, this is a ray of light which is coming from infinity, after striking the mirror, the reflected ray will pass through focus. This is the first rule that we have. Now the second rule that we have is a vice versa of the same, opposite of the same. Now how does it look is, now let's say, I'll draw it separately also, but let me draw it here so that you will understand it. Again I'll draw it in a different, in a new diagram, in a new page I'll draw it. Now second rule says that if a ray of light which is coming from infinity passing from focus, if a ray of light coming from infinity passing through focus, after striking the mirror, it will be parallel to principal axis. Now see, this is parallel. What I mean, this is parallel to principal axis. This ray is parallel to principal axis. The reflected ray will be parallel to principal axis in the second case, wherein the ray of light is coming from infinity. Let me draw this once again for you. This is the second rule that we have. This is a concave mirror. This is PA, pole, this is focus, and center of curvature. As I told you that a ray of light coming from infinity passing through focus, after striking the mirror, it will be parallel to principal axis. Now as you know, in maths we show this sign as parallel to each other. Now these two lines are parallel to each other. That's how after striking the mirror it will be parallel to principal axis. Now the third rule. Third rule says that, let's say this is PA, this is pole, this is focus, and this is center of curvature. Now third rule says that if a ray of light which is passing from center of curvature after striking the mirror, it will retrace its own path. Now see, this is going like this. After striking, again it is coming on the same line. This is going like this. After striking, again it is coming on the same line. This repetition of line from one point to the other, from same point reflecting back, it is called retracing its path. It means it is repeating its own self. That's why a ray of light which is passing from center of curvature, after striking the mirror, it will retrace its own path. If you are not able to get the definition, I request you all to on we have English subtitles over here. You can on it and you can write the definition of the same. As I am repeating it once again, that the third rule says that if a ray of light passing from center of curvature, after striking the mirror, it will retrace its own path. Now the fourth rule that we have is this. The fourth rule says that this is F, this is C. Now the fourth rule says that if a ray of light coming from infinity, when it strikes the mirror at pole, it will, the angle at which it is striking, the angle of incidence at pole, the angle of reflection will also be the same. The angle of reflection and angle of incidence will be same when it is striking at pole. This is the fourth rule that we have. But while drawing the ray diagram, we use only the first three rules that we have. That is only being utilized while drawing the ray diagrams. I'll show you now. Now this is the four rules that you should know to draw the ray diagrams. This fourth rule is not there. We don't utilize this rule to draw the ray diagram. Now moving ahead to the ray diagrams that we have. These are the rules that I have already explained you. This is the third rule. This is parallel to the principal axis. This is the second rule that we have. And now this is all the culmination that we have is shown over here. For whenever the object is at infinity. When the object is at infinity, this is the case number 1. I will draw the diagram myself over here again so that you will understand it perfectly. Now let's say, moving ahead. Now I am drawing the ray diagram for concave mirror. In concave mirror we have 6 cases. Now the one which I will draw it over here now is case number 1. This is case 1. Case 1 wherein object is at infinity. Object is at, let me infinity. Now how does it look? Let's say this is a concave mirror. This is a concave mirror. I have principal axis. I have principal axis. I have principal axis PA. This is pole. This is focus. This is center of curvature. Now, before we go ahead and draw the ray diagrams, I request you all that while drawing this concave mirror, please use it a compass, and you take it center, take a radius of a compass as certain. Let's say you are taking as 6 centimeters. Why am I requesting you to take 6 centimeters, or I want you to keep 6 centimeters for the reason that you will get the diagram perfectly when you will draw it by your hand. When you draw it by your hand, you will get the diagram perfectly. I am drawing it roughly over here with this pen, but when you will draw it, please kindly use it scale and pencil with compass, so that you will get the measurement of the diagram perfectly. Measurement of the diagram perfectly. If you want to get the measurement of the diagram perfectly, like the nature, everything will get perfect when you draw it perfectly with compass and pencil with the correct measurement that you have. Now let's say you people have taken it compass of radius 6 centimeter. As I told you, focus is a central part of center of curvature and pole. Center of curvature and pole. Now, as I already explained, the distance from center of curvature to the pole is nothing but r. That is called radius of curvature. That is called radius of curvature. Now I'll draw the first case. I'll draw the first case that when the object is at infinity. When the object is at infinity. Now, when the object is at infinity, let's say object is at infinity, you don't know where the object is. You don't know where the object is. As a rule, one says that when a ray of light coming from infinity, after striking the mirror, it will pass through focus. It will pass through focus. It will pass through focus. Now this is passing through focus. Now again I will take one more ray diagram. This is rule number 1. Again I will take rule number 1 from below. From below. Now you know that after striking the mirror, it will pass through focus. It will pass through focus. Now you should know that, please note this point, that image formation will take place at point where there is an intersection of reflected ray. Where there is a intersection of reflected ray. Now where the reflected ray are meeting, where is the intersection point of reflected ray is at this point. Now if you can see, this is a reflected ray for this incident ray, and this is a reflected ray for this incident ray. Now these two are meeting at one point. This is the point where it is meeting. Now image formation is at this point. Image formation is at this point. Now if anyone is asking you, what is the characteristics of image that we have got? What is the characteristics of image that we have got is, the characteristics is, now you should know that concave mirror forms real image. Concave mirror forms real image. Now the characteristics of this is, image is real, size of the image. Second thing that we should know is size of the image. Size of the image is very small is nothing but diminished. Now when do we use this word diminished? When do we use this word enlarged? When do we use this word large? I'll tell you now. Let's say I have object of size 2 centimeter. I have object of size 2 centimeter. Now if the image formation, if the image is getting formed which is not of this size, and it is smaller than this size, then that is called diminished. Then that is called diminished. When it is called diminished, when the image formation is of 1 centimeter or less than 2 centimeter, which is the object size, which is the object size. If the image size is less than the object size, then we call that is as diminished. When we call it as diminished. Now, whenever it is of same size, we'll call it as of same size. Whenever the image is greater than this size, then we call it as enlarged. Then we call it as enlarged. Then we call it as enlarged. Now over here, object is at some place that is at infinity. You don't know where is this. It will have some size. It will have some size. But over here, the image nature is point size. Image nature is point size, and the nature of the image that we have is real image. I'll tell you the difference between real image and virtual image in coming forward. After this I'll tell you. Now over here it is real image, it is point size, and it is behind the mirror. It is it is behind the mirror, not outside the mirror. It is behind the mirror. That is, this is the behind the mirror. The real image is something that can be caught on the screen. Real image is something that can be caught on the screen, and it will be inverted. It can be caught on the screen. For example, everyone watches nowadays television. Everyone go for a movie in a multiplex theaters that you have. So the image which can be caught on the screen is called real image, and its nature is will be inverted. Now whenever you write the characteristics and the nature of the image with word real, inverted goes always. So you should say that the image is real and inverted. You should always say that the real is real and inverted. And as I told you, the characteristics is size of the image is point size. It is on the same side of an object. It is on the same side of the object. Now how do you need to write all this? The first, you should write that what is the size of the image. As I told you, size of the image is diminished. Now where the image is getting formed? Image is getting formed at focus. In what case? In the first case, where the object is at infinity. Now what is the nature of the image? Nature of the image is real and inverted. Now these three points is very important. Now the fourth point that I have is the image is on the same side of an object, because as you can see, somewhere over here in infinity I have object, and image is getting formed over here, not to the right hand side of the mirror, only to the left hand side of the mirror. That's why object and image is on the same side of the mirror. That's why the fourth point that we can include while writing the characteristics of the image is the object and the image is on the same side of an mirror. Now this is the ray diagram for the case 1, that is object is at infinity. Now moving ahead for the case 2, where the object is beyond C. Case 2, I am writing it over here. Object is on beyond C. C is nothing but center of curvature. Now this is a concave mirror that I have. So this is the case 2 that we have, wherein the object is placed beyond C. Beyond C is nothing but which is just behind center of curvature. This is center of curvature and object is just behind center of curvature, which is the height of an object is 2 centimeter. Why am I telling you all guys to take the height of an object is 2 centimeter or some measurement you take, whether you take 1 centimeter, so that whenever the image form that you will get, if you will measure that image, that will be definitely either smaller or bigger than the object size. Then you will be able to then you will be able to say the characteristics of the same, whether it is diminished or enlarged or of the same size. Now, as I told you that image formation will take place at a junction or intersection point of a reflected ray. Now, for this, the first ray that we have, reflected ray, is meeting over here, and the second ray that we have, this one is a second ray. This one is a second ray that we have, which is meeting at this point, the reflected ray is meeting at this point. Now, the image formed over here, image is getting formed over here. Now, how the image is? Image is like this. Image is like this, which is opposite. Now, see, object is like this and image is like this, which is inverted. That is, the nature of the image is real and inverted. Now, when you will measure it, when you people have drawn it with a correct measurement, the size of an image will be definitely smaller than the size of the object. Definitely will be smaller than the size of an object. Now, the first thing I told you, that what is the size of the image? Image size is smaller than the object size, which will give me a word called diminished. So, over here we will use the word diminished. Now, after this, where the image getting formed? Image is getting formed between center of curvature and focus. Now, the object and the image is on the same side, or both of them are on the same side. This is the fourth point that you have to include it. Now, likewise, I have 4 more cases which will be coming and I will be teaching, and in the next grade, in the next class, see, whatever diagram I have drawn it, which is there in the book also, this is the case 2 that you have in the book. Object is placed over here. Now, from the top it is going. I have, as I have already told you and taught you, that whenever you people are drawing the ray diagram, always the ray diagram will go from the top of object. Now, the ray diagram is going from the top of an object. This is ray 1. Now, after striking, it is passing through focus. Now, the second rule which we have, the ray of light which is coming from infinity, after passing the focus, it will be parallel to principal axis. Now, you know that where is the diagram is getting formed, where the your image is getting formed, that is getting formed at an intersection point, at a junction of reflected ray of both the rays that we have, which is at this point that you have, I'll mark it so that you will understand. This is the focus. Now, where it is getting intersecting, both of the reflected rays intersecting at this point, which I have already shown in the diagram. Characteristics is, where the first characteristic you should write is where the image getting formed. Image is between focus and center of curvature. What is the size of the image? Size of the image is smaller than the size of an object. That's why we will use the word diminished. Now, what is the nature of the image? Nature of the image is real and inverted. Now, where the image is, the object and the image is on the same side of a mirror. These are the points that you need to include while writing the characteristics of image. Now, we have 4 more cases coming in the next video. Now, I request you all to stay tuned and keep posting and keep commenting on the video, keep liking the video, keep sharing the video, so that I will be able to reach the most of the people who are not able to go to school and not able to study properly, so that it will be beneficial to all of them. Now, thank you so much for watching, and I request you all to please keep commenting, please giving feedback in the form of comments, so that I will keep improving on my video that we make. Thank you so much.